A very good afternoon to all my dear children. Welcome to Analytics Powered Virtual Interactive Classes. So, how are you all? I hope you all are doing great, isn't it? So, without any delay, let's begin our today's class. So today we will continue with the second part of exploring magnets. Isn't it? Now, in the last class, we have studied the first part of exploring magnets, and today we will continue with our second part. So, let's see what we have on the screen. So, here on the screen, we can see that how can we use a magnet to find directions. Means, now we will determine that with the help of magnet, how we can find directions. In the last class, we have studied that with the help of magnet, we can attract materials, isn't it? But now we will continue to study that using magnets, we can find directions. Okay. So, here this one is a what? I think you all of you know this one. Very good. It's a bar magnet. So, what we call this one? This one is a bar magnet. Okay. So, let's see what happened. Here it is written that suspend a bar magnet using a thread tied to its middle. Means it is saying that suspend a bar magnet by tying a thread on the middle of the bar magnet. Means to keep the bar magnet in the rest position. Okay. So here the thread, this one is a what? This one is a thread. A thread is tied on the middle of this bar magnet. Okay. And then suspend means hang a bar magnet with the help of a thread. Okay. Now adjust the position of the thread until the magnet is balanced horizontally. Now it is said that adjust the position of the magnet. As we have hang the magnet with the help of a thread, now adjust that position until the magnet is balanced horizontally. Horizontally means this plane and vertical means this plane. Until the magnet is balanced horizontally, adjust the position of the thread. Horizontally means this direction. This direction is the horizontal direction. Okay. And this part is called the vertical direction. Okay. So, let's see. Now gently rotate the magnet in the horizontal plane and allow it to come to rest. Now it is saying that now give a gentle move to this bar magnet and in the horizontal plane and wait until the magnet comes to a rest position. Okay. Let's see. See. Now here what we have done? We have given a gentle push to this bar magnet. Okay. And this bar magnet is moving and slowly it will come to its rest position. See. Now before it was moving so fast and now it is moving little slowly, isn't it? And see, slowly it will come to its rest position. See. Now it will come to its rest position. See, after some time, it has come to its rest position. Now it is said that mark the positions corresponding to the two ends of the magnet. Now it is said that mark the positions to the two ends of the magnet. Okay, this one is a magnet, so its two end will be this part. So it is said that mark the two position of the two ends of the magnet. See, these are the what? These are the two ends. So now mark this position. See, we have marked this position on the two ends of the magnet. And then what comes? Join these 2 points with a line. After marking the two ends of the magnet, join these 2 points. Okay, join these 2 points with the help of a line. See, now these 2 points are joined with the help of a line. Now it is said that this line indicates the direction along which the magnet rests. Now the line which we have joined, this line what it indicates? It indicates the magnet rest in which direction? See, the magnet rests in this direction, isn't it? And even the line is also this side. That means we can say that the line which we have joined with the help of the two endpoints of the magnet is the line the magnet rests, isn't it? Let's see. Now, it is said that again rotate the magnet by giving a gentle push at one end and wait until it comes to rest. Now, again it is said to repeat the activity. Again to give a gentle push to the magnet and observe until it come to its rest position. Okay, see. Now again he gave a gentle push to this magnet and now the magnet is moving, means it rotating, and after some time it will again come to its rest position. Okay. And then we will observe in which position, in which direction it has rest. Okay, see. Now what happened? Now does the magnet rest along the same line? Now do you see the magnet rest along the same line? So these endpoints are the 2 points, isn't it? These endpoints are the what? 2 endpoints of the magnet. So if we join this line like this, see, in this direction the magnet rests now, and before the magnet, before in which direction the magnet rests? In this direction. Okay. So we can say that what direction does a line along which the magnet rest indicates? Means which direction? This direction. In this direction the magnet rests. Now how can we find them? Now how can we find them? See, we can find the direction. Before we have find out by giving the dotted line, by giving the marking the two endpoints of the magnet, and then we have joined that 2 points. Like this we have find the line in which the magnet rests. Okay, but in a real life how we can find? We can find with the help of the direction of the sun. Means whether in which direction, in the north direction, in the south direction, in the east direction, or in the west direction. In such a case we can find those direction with the help of the rising sun. Okay, so how we will find? So let's see. Now we can see that the boy is standing by giving his face towards the sun. Okay, in which side the sun comes out, in that side the boy is looking towards the sun. Okay, so that direction will be what? That direction will be east. Okay, and then the direction opposite to the rising sun will be what? Will be west. And the direction to the left of the rising sun, means the direction left of the rising sun will be what? Will be north. And the direction right to the rising sun will be your south direction. Okay, means how will you determine? Suppose in this side the sun rises. Okay, you will stand towards this side, and this side will be what? This side will be your east direction, and opposite to this side will be your west direction, and left of this side will be your north direction, and the right of this side will be your south direction. Okay, like this way we can find the direction by using the rising sun position. Okay, see here the east, west, north, south. Then this one is a what? This one is a magnet. Okay, means this one is a magnet. So even in the magnet also we can indicate the directions. Suppose in this side the sun rises. Okay, this side what? This side is the sun rises. So if we stand towards the rising sun, this position will be east. We are denoting it by the E. And then opposite of the rising sun, which one? This part, the opposite of the rising sun will be west. We are denoting it with W. And the left of the rising sun will be north. We are denoting it by N. And the right of the rising sun will be south. We are denoting it by S. Okay. So like this way we can denote the directions with the help of the position of the rising sun. Let's see. Now this one is a what? This one is a bar magnet and this one is what? Magnetic compass. Okay. So in the bar magnet, we know that in this direction the magnet rests. Now what is this direction? Which direction? East, west, north, south. Which direction? How will we find out? So here we will see. Now this one is what? This one is the sun. Okay. What I said? If we stand towards the sun, this position will be considered as the east. Now this one is the sun, okay, and this position near to it will be what? This one will be east. Then opposite of east, which direction? This direction. Then opposite of east will be what? West. And then left of east means left of rising sun will be what? This direction. Left of sun, rising sun means north, and then right direction of the rising sun will be south. Okay, so so like this we can determine the positions. Okay, before before we have seen this direction the sun was there, and now in this direction the sun is present. Okay, and if we consider this direction, we can denote the four positions of the east, west, north, south. Okay. Excuse me. So let's see what we see next. A freely suspended magnet always rests along the north-south direction. Now, here's a statement that a freely suspended magnet means a hanging magnet will always rest along the north-south direction. Okay, so north-south direction, how we will determine? See, the end of the magnet that point towards the north is called the north-seeking pole or the north pole of the magnet. Means the end point of the magnet. Suppose this is the end point of the magnet. So if that end point is directed towards the north-seeking pole, we will call this one as the north pole of the magnet. Or if it is directed towards the north direction, we will call it the north-seeking pole. Okay. Or if, see, this one is a north position. Okay, because the magnet rests always horizontally, and this part is what? This one is a horizontal part, and this one is a what? This one is a vertical part. So along the vertical part we can see east and west, and along the horizontal part we can see north and south. So we can conclude that the magnet always rests along the north-south direction, because the magnet rests along the horizontal plane, isn't it? And the other end which points towards the south is called the south-seeking pole or the south pole of the magnet, and the other end of the magnet which is pointing towards the south direction, we call it the south-seeking pole or south pole of the magnet. In every magnet there is two poles, north pole and the south pole. If the end point of the magnet is pointing towards the north direction, then we will call this one as the north-seeking pole or the north pole of the magnet. If the other end of the magnet is pointing towards the south direction, we will call this one as the south-seeking pole or the south pole of the magnet. Okay. So this part is the what? This part is the south pole. Okay, see, this one is the south pole and north pole, and this one is a bar magnet. So this one is the south pole and this part is the north pole. See, this part is the north pole and this part is the south pole, and the magnet rests along this direction. Along this direction the magnet rests. Now, but why does a freely suspended magnet rest along the north-south direction? Now the question is that why a freely suspended magnet always rests along the north-south direction? Why not east-west direction? Now the question is that why it is always rest along the north-south direction, isn't it? See, this one is the magnet and we can see that even beyond the Earth's surface some magnetic fields are generating, isn't it? Now it is said that a freely suspended magnet rests along the north-south direction because the earth itself behaves like a giant magnet. Giant magnet means the earth itself behaves like a huge magnet. Because of this huge magnet, the earth generates a magnetic field beyond the surface, isn't it? Suppose this one is a magnet. Okay, and now it will generate the magnetic field this way. This way it will generate the magnetic field. Similarly, this one is the earth, and now it is generating the magnetic field this direction. In this way, the earth is magneting the the earth is generating the magnetic fields, isn't it? And these magnetic fields attract the bar magnet and align itself in the north south direction. Okay, as the earth behaves like a huge magnet, this earth is now generating the magnetic fields. Okay, and because of this magnetic fields, what the magnetic fields attract the magnets and aligns itself in the north south direction. Okay, so now it is here, it is, this one is said. Let's see what we have next. Now repeat this activity using a small iron bar or rod instead of bar magnet. Before we have performed the activity with the help of the bar magnet, and then we came into conclusion that the bar magnet always rests along the north south direction. Okay, and now we will perform the same procedure activity with the help of the iron bar or iron rod. Okay, this one is the iron bar. Okay, iron bar or iron rod. So we can call this one as iron bar or iron rod. Okay, we'll perform with this iron bar or iron rod. Now again we have given a gentle push to this iron rod, and we will wait for the time when the iron rod comes to its rest position, and then we will observe in which direction the iron rod comes to a rest. Okay, see, now also it's rotating. Now after some time it will come to its rest position. See, now it has come to its rest position, means in this direction the iron rod came to rest position, isn't it? See, this direction. And then again what we did? Again we repeat the same procedure by giving a gentle push to the iron rod again, and then again we will wait until the iron rod comes to its rest position. Okay, see how the iron rod is rotating, and after some time it will come to its rest position. See, just wait for a time, let it stable. See, now the iron rod came to the rest position, and now it is resting in this direction, isn't it? Before it was resting in that direction, and now it is resting in this direction. Now children, tell me, now both the direction are similar, means both the direction now is similar to each other. Before the iron rod, in which direction it has came to its rest position, and after the second procedure, after the second time we repeat the activity, in which direction the iron rod came to the rest position, both the position are similar. No, both the positions are not similar. What do you observe? What do you observe from this activity? Does it always rest along the north south direction? See, this direction we can say this one is the north south direction, this red dot line. This one we can say this one is the north south direction. Okay, and now children, can you tell this direction as the north south direction? Because the north south direction always lies in the horizontal plane, and this one is a what? This one is a horizontal plane, but the before one, is this a horizontal plane? Can you tell me that now the before also the iron rod rests in the north south direction? No, we cannot say, because both are different directions. It can rest in any direction, and now we can say that iron rod can rest in any direction. Before it was rest in this direction, and after that it was rest in this direction. Sorry, let me repeat it again. Before it was resting along this direction. Okay, this one we will consider is A, and after that this was resting along this direction. We will consider it B. So now children, you can compare that both the direction A and the direction B are along the same pattern. See, A is going this side, A is going this side, and B is going this side. So both are not along the same direction. Okay. So only a freely suspended magnet rests along the north-south direction. Not all the materials. Only a freely suspended magnet. Freely suspended magnet means when we hang a magnet with the help of a thread. That position we call a freely suspended magnet. Only such kind of magnet rests along the north-south direction. None of the material will rest along the same direction. It will rest along the different directions, like we have seen in case of iron rod. But the magnet, the freely suspended magnet, will rest along the north-south direction. How many times you give a gentle push for the rotation, at the end of the rotation it will come to a rest along the north-south direction. Okay. The property of freely suspended magnet to always rest along the north-south direction is used to find directions. Now, this property of a freely suspended magnet, that is rest along the north-south direction, this property help us to find the directions, because we know that the bar magnet means or freely suspended magnet always rest along the north-south direction, and this property help us to find the directions. Okay. So here's a note down. A freely suspended magnet rests along the north-south direction. We have studied this one before, that a freely suspended magnet always rests along the north-south direction. Okay. So children, now it's your question time. Your first question of the today's class. Let's see what question you have. To ensure a suspended magnet aligns correctly, it should be kept away from option 1 wooden furniture, option B plastic bottles, option C other magnets or iron objects, and option D glass windows. And I will give you another 30 seconds of timer. You need to give the correct option. Okay, just use a bit of concept you have studied. I taught you. Just use some concept. You will able to answer this question. Okay, so let's start the timer. So your time has started. I can see many of you have given the correct option. Others, please keep answering. We know that all the magnetic materials get attracted to what? Which kind of materials? You know na? So here your time's up. So I can see many of you have given the correct option. Very good. So the correct option is option C. So let me discuss the question with you. To ensure a suspended magnet aligns correctly, each should be kept away from wooden furniture, because a magnet will not get attracted to the wooden furnitures. Plastic bottles, even the magnet will not get attracted to the plastic bottles. Other magnets or iron objects, yes, the magnets will get attracted to the other magnets or iron objects. If any magnets get attracted towards the other magnets or iron objects, it will change its direction. Because we have seen before that the bar magnet rests along the north-south direction. Why? Because beside this no other magnetic materials were present. Okay, so that's why the bar magnet rests along the north-south direction. If any kind of magnetic material would be present on both the sides, then the what? Then the bar magnet will not rest in the north-south direction. Okay, it will change its direction for the resting position. Okay. So the glass windows, obviously not. The magnet will not get attracted towards the glass windows. Okay, so the correct option is other magnets or iron objects. Okay. So children, tell me what is this? We all know this one. We have studied before. This one is a what? This one is a magnetic compass. This one is a kind of magnetic compass. Okay. See, it's a magnetic compass. So let's see what is written. A magnetic compass is a small device developed in olden days for finding direction. So this magnetic compass is a kind of device, is a kind of small device which was developed in the ancient times in order to find the directions. In the olden days, in order to find the directions, this magnetic compass device was invented. Okay. See, and this one is a what? This middle part. It contains a magnet in the shape of a needle that can rotate freely. Means this magnetic compass contains a magnet in the shape of needle. Means it is having a magnet of needle shape that can rotate freely. Because needle shape is this part, this one. That means what? This needle is consists of magnet. This one is what? This one is a needle. So this needle consists of magnet and this needle can rotate freely. Okay. Now the needle of the magnetic compass aligns itself along the north-south direction. As the bar magnet always aligns itself in the north-south direction, after the rotation, when it comes to a rest position, it always rests in the north-south direction, the bar magnet. Even the magnetic compass also, even the needle of the magnetic compass also comes to and rest along the north-south direction. Okay, even the bar magnet also rests along the north-south direction and even the needle of the magnetic compass also rests along the north-south direction. Okay. Now here's a more to know. You can know so many things. A magnetic compass is usually a small circular box with a transparent cover. Means this magnetic compass, this one is a kind of device. This magnetic compass is a what? This is a device, kind of device used to find the directions. Now this magnetic compass is usually a small circular box. Circular means what? Round shape box. See, this one is a round shaped box. This magnetic compass is a kind of small circular box with a transparent cover. Means the cover of the magnetic compass is of transparent so that it's visible to us or about the needle and the directions which are indicated in the magnetic compass. So that we can see the things inside the compass. That's why the cover of the magnetic compass consists of transparent. Okay. See, now what? Now this needle is showing something. Inside the box, a magnet in the shape of needle is mounted on a pin fixed at the bottom. Means inside this magnetic compass box, this middle part is consists of a pin and this needle is mounted on this pin. Suppose this is a pin and the needle is mounted on this pin so that the needle can rotate freely. That's why the needle is mounted on the pin so that the needle can rotate freely. Okay. The needle is balanced on the pin in such a way that it can rotate freely. Now, this needle is balanced on the pin in such a way that it can rotate freely. Okay, in such a way it is balanced that it can rotate freely. Okay. Now, the end of the needle that points towards the north is usually painted red. Now, the needle which points towards the north direction is painted with a red color. Okay, see this part. This part is painted with a red and this indicates north direction. Red indicates north direction. Okay. In the needle, which part is painted with the red color? this part is indicated as the north direction. Okay. And now below the needle is a dial marked with direction. Now below the needle means this part, all this part. Now below the needle is a dial. Dial means what? This part. So this part is dial, this dial is marked with different directions. Okay. Below the needle we can see this one is the west, this one is the east, this one is the south, this one is the north. So all these directions are indicated below the needle, and the needle is mounted on the pin and it can rotate freely, and all these directions are indicated below the needle, so that in which direction the needle gets stopped we can indicate that this direction is the east, west, north or south. Okay. So now how to find directions using a compass? Now using a magnetic compass, how we will find the directions? Because using a bar magnet we have seen how to find the directions, and now using a magnetic compass, how we will find the directions? Okay. See, place the compass on a flat surface at the location where you wish to determine the directions. Now place the magnet in such a part, in such a place in which place you want to determine the directions. Okay. Then after a short time the needle settles along the north-south direction. Now after some time we will observe the needle settles along the north-south direction. Now the needle is this part, and this one is the north, this one is the south, this one is the west, this one is the east. See, this one is the south, this one is the north, the west, and this one is the east. But the needle is along this direction. Okay. After some time, we will see the needle rest along the north-south direction. See, gently rotate the compass box until the north and south markings on the dial are aligned with the corresponding ends of the needle. Now it says gently rotate the compass box so that the north-south directions or markings on the dial are aligned with the corresponding ends. We have I said before that red part will indicate as the north direction. So we will rotate the compass in such a way that the red part comes along the north direction, means this direction, and the other part goes towards the south direction. In such a way we will rotate the needle, we will rotate the compass and the needle will takes place in its direction. Okay. See how slowly he is rotating. So there the red end of the needle comes towards the north position. See, and now we can see that the red end of the needle comes towards the north position. Okay. So now all the directions are as indicated on the dial. Now we can see that all the directions are now indicated on the dial. See, this one is the north, it's indicated, this one is the south, this one is the east, and this one is the west. Okay. So like this we can indicate the direction by using a compass, by using a magnetic compass device. Okay. So that's all for you today's class. I hope all of you have understood the classes. Today we have learned with the help of the bar magnet how we can find the directions, and we have learned with the help of the magnetic compass device how we can find the directions, and the rest part we will continue in our next class. Okay. So till then, take care, be happy, keep studying. Bye.